Hello, welcome back. I forgot to introduce myself in the last lesson. If somebody were to come and directly join in this lesson, for those people who are joining just today for this lesson, my name is Sosale Mohana. I'm a maths teacher who has taught maths in 3 different countries for a total of 50 years plus, and I have mainly taught A level for the maths, and these lessons are to help people revise topics they have learnt in school. Please understand, this is not a replacement of your classroom lesson, it's a revision. So you learn everything from your teachers who are doing a fantastic work. My job is only to help you go over what your teachers have taught you. Thank you very much. Let's proceed. So last time I talked about, as you can see, I've left the things there. We were talking of logarithms, and today I want to introduce you to natural logarithms and graphs, or the logarithmic functions, right? Remember, to define a logarithm, we use an exponential, a power x equal to b or x power a equal to b. So in other words, y equal to a power x. If f of x is equal to a power x, then the graph is like this, correct? From there, I've got f inverse of x is equal to log a power x, then log ln x is log x to base e power x. So log x to base a. The graph of log x to base a will be like this. Idiot. They will be reflections of each other in y equal to x. So a power x and log x to base a are inverses of each other. So then, in other words, I have to, but more importantly, we don't use a letter a. What happened was, even though it's very convenient to use base 10 and it's a bit cumbersome to use base 2, base 5, base 7, imagine there is a number called e, which is 2.718 something something something, which I will discuss in detail later. This is the Napierian base. Napier was the mathematician who has been honored with the letter, the Napierian base log to base e, whereas the letter e is in honor of one of the greatest mathematicians of this millennium, the last millennium, Euler. Some people pronounce it as Euler. EU, there's a double as a German mathematician, Euler. So this letter E is attributed to him, and Napier came up with the logarithms to base E, which is going to haunt your life in differentiation, in integration, and differential equations, in further pure maths, at university work, wherever you go, you will come across that number E. Is one of the most important numbers, like pi. Remember, from year 6 to perhaps year 11 so far, or year 12, you have been bugged, you have been bombarded with pi, 3.142. Same way, you start in year 12, goes on for the rest of your academic career, and if unfortunately become a teacher like me, or a pure mathematician or an engineer who's going to work on research, you will be bombarded with E every now and then. So again, don't have to copy this. The function y equal to e power x and the function y equal to logarithm of x to base e, which is accepted norm of writing is ln x. You know, we maths teachers are lazy. We don't want to write log and x and e. So we write ln. ln is accepted. The moment you see the letter ln, you assume the base is e. ln x and e power x are the two most important functions in your life as a student of maths. Okay? So, if f of x equal to e power x, then f inverse of x equal to ln x. If f of x equal to ln x, then f inverse of x equal to e power x. E power x is defined for x belongs to R, ln x is defined for x belongs to R, x greater than 0. So, the range of e power x from the graph is y belongs to R, y greater than 0 becomes x belongs to R, x greater than 0. Remember when we did functions, if you've gone listen to me or gone through the notes, you see the domain of f is the range of f inverse. Sorry, yeah, but the range of f is the domain of f inverse. Similarly, anytime I give, so this must be x belongs to R, x greater than 0, and this is x belongs to R. Right? Then f of f inverse x is x. Remember that also I showed you. So, e power ln x is x. Then ln e power x is also x. Please understand these two. You will come across these in integration and differential equations and differentiation. So, at that time, I'm not going to go over again the whole theory, or your teachers will say, look, I taught you before. Remember. So, you must remember e power ln x is x. ln e, the moment you see ln e or e power ln, e and ln, mentally you can assume, even though mathematically not correct, they're inverses of each other, or they cancel each other, you're left with x. They cancel each other, you're left with x. Right? The third relation is which sometimes I have seen a question in an exam using the fact that a power x equal to e power x ln a, or otherwise differentiate. So, show a power x, I think this in your Excel formula book, show a power x equal to e power x ln a. Why? So, let's start with e power x ln a is equal to e power ln a power x. Remember, these are inverses of each other, so which is a power x. So, when you want to differentiate a power x later, you will use e power x ln a and the derivatives of an exponential function. So, let me put all those things here. F of x equal to e power x, f inverse of x equal to ln x, ln e power x equal to e power ln x equal to x, and the most important thing, I'll put it here, a power x equal to e power x ln a. I don't know whether I'll be using these, but I thought I would show you so that you remember these things. I mean, it will be in the handout which I'm giving you, so it shouldn't be a problem. Let me see if I can solve some other equations. For example, simplify. I thought I had written some questions. Yeah. I should have written some questions. Looks like, yeah, I haven't written any questions on these. Let me just show simplify using ln. Simplify to a single logarithm. Single ln function. Or sometimes they say giving your answer as a single logarithm. So you should know how to do it. I'll just take an example. Okay. Half log x minus 2. After integration, you got half ln x minus 2 plus half ln x plus 2 minus 3 ln x. I can't combine. The rules still apply. Just because ln doesn't mean it's different. Ln is nothing but logarithm to base e. So therefore, I can't simplify unless I get rid of these numbers. Get rid of means you can't multiply through it by 2 because there is nothing to multiply on the other side. That means write them as powers. So it is ln x minus 2 power half plus ln x plus 2 power half minus ln x cube. Now it is log to base e x minus 2 power half log to base e x plus 2 power half log to base e x cube. So it is log to base e square root of x minus 2 times square root of x plus 2 over x cube, which is ln root x squared minus 4 over x cube. Sometimes they say show that the answer is ln x square root of x squared plus a over x power b, stating the values of a and b. Then you are asked to express like this. From there you figure out what's your a, what's your b. Alright? Why I'm taking this is because when we do integration, we will come across questions like this. Right? Now, 2 plus 3 ln a plus ln b. 2 plus 3 ln a plus ln b. The question is still the same. Express as a single ln function. 3 ln a can be written as ln a cube. Ln b is ln b. Thank God for that. But the number 2. If it was 10, I would say log 10 to base 10. But I have got ln, so I can call it as, I'll do it here, 2 equal to 2 times 1, which is 2 log e to base e, or 2 ln e, or ln e squared. You can simplify only when you have ln's. So that's ln e squared. So that's ln of a cube b e squared. There you have simplified it into 1 ln. Good. I don't think so. And sometimes they say drawing a sketch, so I'll just leave it for you people. This is the graph of e power x. You should know the graph. And this is the graph of ln x. And they are reflections of each other in the line y equal to x. I think I have a bit of time to show you one example on how to find inverse. Okay, let us see. Given that, oh, it's not x, it's a typical A-level, it's a typical A-level question. Given that f of x equal to e power 2x minus 1, x belongs to R, find f inverse x stating its domain. A typical 3 or 4 mark question. Now, how do we do this? You know the graph of e power x. Going through 0, 1. E power 2x, suppose let me do it somewhere here. Let's say g of x is e power x. G of 2x will be e power 2x. Let's go back and remember the transformations. The change is inside the bracket, so affects x. The change is inside the bracket affects x in the opposite way. So if it is 2x, the values will be multiplied by half. Meaning y values don't change, x values are multiplied by half. For example, if this was 1 and e, it will be half and e. In other words, the graph of e power 2x will roughly be, oh, where's my red pen? It has fallen down here. Will roughly be, it passes to the same point, but it is a stretch parallel to x-axis. Half and e, 1 and e, let's say that's 1 and e, half and e will be here. So this is e power 2x. But then minus 1. What is e power 2x minus 1? Will be g of 2x minus 1. The change is outside the bracket, so affects y. And if with y, it's the same way. If it is minus 1, it will come down. If it is plus 1, it will go up. Whereas with x, if it is minus 1, it moves to the right. Plus 1, it moves to the left. So therefore, the graph moves down by 1 unit. It's a translation by 1 unit. So therefore, 0, 1 becomes 0, 0. The asymptote was y equal to 0 becomes the asymptote y equal to 1. This would be the graph of y equal to e power 2x minus 1. Now, why am I drawing the graph? Because I just found the inverse, calling it as y and then taking log and this and that. Why are you finding the inverse? Two reasons. The question wants the domain of f inverse. To find the domain of f inverse, you should know the range of f. To know the range of f, you should draw a graph. That's why I did it. Also, I wanted to go over how to sketch e power x graphs. So it's 2 in 1. 2 birds in 1 stone. Yeah? Good. So therefore, what is the range of f? I'm going to put the same one in or a similar example in the handout. So range of f is f of x or y belongs to R, y greater than or equal to 1. So the domain of f inverse will be x belongs to R, x greater than 1. Okay? Good. Now I must find the inverse. How do I find the inverse? I'm recollecting what we did. Call the equation as y equal to e power 2x minus 1. No, it's here. Minus 1. Then y equal to e power 2x minus 1. So e power 2x equal to y plus 1. 2x equal to ln y plus 1. X equal to half ln y plus 1. So f inverse x is equal to half ln x plus 1. X belongs to R, x greater than minus 1, not 1. Sorry, x greater than minus 1. Why? Even otherwise, at x equal to minus 1, is log of 0, which is not defined. If x is less than minus 1, x plus 1 will be negative, again not defined. So for this function to be defined, x has to be greater than minus 1. So perhaps if you can remember the properties of a log, you need not draw the graph the way I did it. By looking at the answer, remember we did this in rational functions, you can figure out what the domain for the inverse or the range of the original should be. So let me put this here as well. So ln of 0 not defined, ln of negative not defined. So what I have done is so far given you a brief introduction to logs and gave you a glimpse of what kind of questions you're going to expect when you go to A2. and how to simplify logs, and most importantly, how not to use the Paris rules for logs, because that is a very common mistake I've come across every time. Even some of my further math students commit these mistakes who are supposed to be very good in maths. So be careful. You can use these rules, but you can't find log of a plus b in bracket, can't be simplified. Log of a minus b in bracket can't be simplified. Please don't try to formulate your own rules. If you want to do it, as I told you, book a ticket to Paris. Have a nice day. Bye bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.